We've spent quite a bit of time talking about ratios and proportions, and now we're going to add rates to this conversation. And the great thing about rates is they're very similar to ratios, but they are a specific comparison of two quantities. We work with rates all the time in real life. One thing that you can do is you can start off by checking your pulse. So let's say that your heart rate is 59 beats in a minute, and someone else that you know is 47 beats in a minute, and someone else that you know is 63 beats per minute. Well, if we were to write this as a ratio, this would simply be 59 to 1. If we were writing it as a rate, it would be 59 beats per 1 minute. So we're essentially saying the same thing. We're just putting more detail into it. We're adding our wording into the ratio. So your friend here would be a 47 to 1 ratio, which would be 47 beats in 1 minute. And your last friend would be a 63 to 1 ratio, which is 63 beats in 1 minute. And it's beneficial to determine the rate for each person here to be able to compare. So this lets us know, if you think about medicine, if someone has a high pulse rate, that means that they're high compared to most people their age and their same health status. So when you're looking at rates, rates describe the comparison by division. That's why they look like a fraction, because we compare by division two quantities that have different units: miles per hour, meters per second. Okay? Unit rate describes the amount per one, so the amount for one, or the rate when the denominator is 1. And this comes in really handy if you're shopping for something and you want to find out, well, if I buy the Keurig K-Cups here and it's 37 cents per unit, or do I buy the ones that are on sale, making them 25 cents per unit? And so you can compare prices and see what your better deal is. So let's look at some situations here. Let's say that Sam can do 120 jumping jacks in 2 minutes. As a ratio, this would be 120 to 2. For a unit rate, remember unit rate means for one or per each. Either way you want to look at it. That means that we need to change that so that we have 1 in our ratio as that second number. So I simply took 2 and divided by 2, like I simplified this problem. So 120 divided by 2 then would be 60. This would give us 60 to 1. So the rate for Samuel, he can do 60 jumping jacks in 1 minute. A large plane is able to cruise at 530 miles per hour. So our ratio would be 530 to 1. I know it's 1 because it says per hour. So then my unit rate is 530 to 1. So when I just look at my overall rate, we have 530 miles for 1 hour. One more. A babysitter gets paid $60 for 4 hours of work. So our ratio would be 60 to 4. To write this as unit rate, I know I'm going to divide by 4. 60 divided by 4 is 15. So that means that this babysitter makes $15 per hour. So for 1 hour. Ratios can also be used to solve problems and to make predictions. So we're going to be making some predictions here based on these methods of transportation. We're going to be using that cross multiply and divide strategy that we've been practicing. So we have a car that traveled 408 miles in 6 hours. We have a dump truck that traveled 236 miles in 4 hours. And we have a bicycle that traveled 153 miles in 9 hours. So we've got to figure out for A, at this rate, how many miles can the dump truck travel in a 7-hour day? So I'm going to set up the skeleton of my proportion here. And I know that I am comparing miles to hours. because that's what this problem is talking about, miles and hours, miles and hours. And we know that the dump truck traveled 236 miles in 4 hours. So we need to figure out for 7 hours. So my unknown is the miles. So I'm going to cross multiply. So I'm going to take 4x, and I'm going to set that equal to 236 times 7. So that means I have to multiply 236 times 7 as my next step. Let's see, that's 42, 21 and 4 is 25, 14, 15, 16. I get 1,652. And then I'm going to divide both sides by 4. So that's going to give me 413 miles in 7 hours. And we're going to stop right here and begin on our assignment that is on formative.